Alright, this is how I would do it.
Go Steve.
First things first, identify my parent chain. It's gonna be starting with whatever has a double bond, if there's a double bond there. If there wasn't a double bond here, then I would look at which one of these is the highest priority, which doesn't really fucking matter, because these are all fields. But this one, sorry, I probably shouldn't cuss, I'm recording myself. So this one, the idea is that because this has to be 1 and 2, because it's a double bond, right, for carbons 1 and 2, then the idea is that I want to try to give any substituents that are hooked up to this the lowest possible number. So if this was over here, this would be 1, but because this is over here, this is now carbon number 1, right, in terms of like the parent name of my structure.
Why that and not the other?
Because this gives the isopropyl group here the number 1.
Yeah.
Versus this over here, if I do 1 here, this one still has to be 2 if I make this 1. And so this makes this 2 isopropyl. Doesn't really make sense because you want to try to get the lowest possible numbers because you're going to have to number this crap anyway, you know? So the idea is that you want to try to give the lowest possible numbers as you can when you're doing this. So the idea is that this is carbon number 1, carbon number 2, carbon number 3, carbon number 4, 5, and 6. Because no matter what, like even if you did 1, 2, and then you have 3, 4, 5, 6, you're still ending up with stuff that are on the 3, 4, and the 6 in terms of these.
And why don't you keep numbering your 6 to 7, 8, and 9 out to the other one?
So you don't want to go in or out of a ring with numbering. So the idea is this is a 6-member ring, and this has more carbons than all of the rest of these do. With the idea that this only has 4, this only has 4, this only has 4, and this only has 3. So you don't want to basically go in or out of a ring whenever you're numbering, because like you just can't, that's just a rule. But like if you had this ring and one of these had like a long giant chain on it, and there was double bonds in here, then you have to look and see what has more double bonds. I don't know how much of this can actually be seen on the camera from right here. But like, yeah, the idea is if you have, you know, like if this wasn't a sec-butyl or whatever, which is just one of the things you have to memorize, if this had a long chain on it and there's a double bond here and a double bond here, well now you've got more carbons on this chain than in the ring, so then this becomes the parent chain, or whatever. It has more double bonds and more carbons.
Okay.
What if that you had that scenario, but no double bonds, but that was longer on the right?
This has a double bond.
That's still priority.
This still has priority double bond.
Okay.
So even if this was really long and it didn't have these double bonds, don't matter. This has priority. There's another practice problem that actually has that exact scenario where you have a ring, it has like the cyclopentyl ring on it, but there's a double bond and there's less carbons for that ring, but because it has that double bond, that has priority.
Okay.
Same thing as if you see this and this is, and you see like a triple bond, you're never gonna see a triple bond inside a ring, but if you see a triple bond, you know, like, and you don't see anything else that is like double bonded or whatever, like that triple bond also has priority in terms of like a parent compound, because it's double bond, triple bond, and then single bond. Make sense?
Mm-hmm.
Okay. So now that we have our like carbon things numbered here for the parent chain, we know that this has 6 carbons, which means this is, and it's in a circle being a loose term. So this is a cyclohex, and then there's a double bond, so it's an ene. Okay? Because the ene group is on carbon 1, you don't have to number it if it's carbons 1 and 2. If this was on, if there was some other double bond somewhere and you have a double bond, like whenever you have really long chains and you have a double bond in the middle of it, you have to number where that double bond is, because you can't just imply that it's somewhere in the chain. So I know there's one that talks about it being a 3-ene or whatever, and a 6-ene and whatever, and then that's kind of where that comes from. Just so that you can identify where that double bond is located. So the next step that I would do is I would identify my groups here, right? So I always just go in a circle. Doesn't matter which direction you go in, as long as you're identifying what they are. So this is isopropyl, and the idea is iso means cut. the idea is that you have 1, 2, 3 carbons, so it's a propyl group or a propane group, and it's cut because you're basically cutting it down the middle into 2 halves. So that's where the isopropyl thing comes from. This one is an isobutyl, and it's butyl because it's got 1, 2, 3, 4 carbons, right? But it's an iso because it's cut right here. So that's, and basically I just like to think that it's an isopropyl plus a butyl. So there's that one. This one is just chicken foot, so it's T-butyl. Okay, very ugly B. And then this one looks like a C. Looks like a C. So I just think sec-butyl. And all of these have 1, 2, 3, 4, 1, 2, 3, 4. Now I have 4 carbons, right? So at that point I say, cool, I know what my substituent groups are. So then I say, okay, let's number out my substituent groups, just so I have an idea of where they are. So I'll write it out in order whenever I'm done, but I'm just gonna go with the same thing where I'm writing out where they are. So 1 isopropyl, 6 isobutyl, 4 T-butyl, and 3 sec-butyl. So I've got those constituent groups. So now I kind of have to figure out what my R's and S's are for this. If it's inside of a ring, you do not do E or Z. Okay?
Real quick, sorry. Did you explain to the viewers where you got the numbers in front of your substituents?
Oh, I did not explain to my viewers. So the idea is that these numbers come from where it is located on the parent chain. Good job, guys. Thanks. You can tell I don't do this as like I'm not a streamer. I'm too old for that shit.
We had that as a live question actually right now. That's why we asked.
Yeah, live questions. I love it.
We have it on live right now in the comments.
Yeah. So the idea is that 1, 2, 3, 4, 5, 6 being your parent chain. So your numbers here just come from where those are on the parent chain. I like having you guys here for this because you're gonna ask the questions like that. I'm like, I'm just gonna do it. So yeah. So this is basically the base for our naming. Like if we didn't have to find our R and S groups, this would give us what we need to know in order to name this structure. The idea is that now we have to find our R and our S groups. So we want to look at the fact that we've only got this one double bond. It makes it really easy to find our R and S groups. If there's more than one, it makes it a little bit more difficult. We have other ones that are like that in the practice problems. But I'll just start with this bond here first, or this carbon here first. This is stereocenter, basically is this carbon right here. Okay, so I'm looking at everything that is connected to that carbon. The biggest thing is that double bond is there, and because there's only the one double bond, that's bond number 1 of my, whatever I'm treating my RNS groups, of my chiral center. Because this carbon has this double bond attached to it. If you don't see a double bond, then you have to start kind of figuring out like how many carbons, hydrogens, all that kind of stuff, which is what Dr. Pelfrey likes to do. I just like to say, okay, cool, I'm looking at this, and I go, okay, cool, I have carbon here, how many things are bonded to it? 1, 2, 3. How many things are bonded to this one? 1, 2, 3. They're the same. Okay, cool, let's move on from there to the next thing down the line. And I usually try to move to whatever has the most bonds. So this one moving out has 1, 2 things bonded to it that are not hydrogen. I don't really give a shit about hydrogen. This one moving out, you have 1, 2, 3, 4 things bonded to it.
What's number 4?
4.
Okay.
So 1, 2, 3, 4 things bonded to it. It's a butyl. It's a T-butyl. So this has 4 things bonded to it. So that means this is number 2, right? Next thing looking at is there's like not a 4th bond we have to worry about with this stereocenter. So if there's not something drawn in, try to draw it in. So we know that because there's 1, 2, 3 bonds to this carbon, and carbon always likes to have 4 bonds, that fourth one is gonna be a hydrogen, right? So this is always number 4, which just leaves number 3 over here. So then we see 1, 2, 3 moving that in a clockwise direction, which is therefore R right there. So then we say R at 3, at this third carbon of the parent chain. So it's 3R. Okay? Going to the next one. At the fourth carbon spot, we do basically the same thing. So we look at what's bonded to this, and we say, okay, well this carbon here, this stereocenter here, this carbon has 4 things bonded to it. This carbon has 2 things bonded to it that are not hydrogen, because we don't really give a shit about hydrogen. This carbon has 3 things bonded to it. So this is actually a very easy one to figure out in terms of just looking at how many things that are not hydrogen are bonded to it. This has 4 things bonded to this carbon, that's number 1. This has 3 things, that's number 2, again, so I'm not gonna put down that 2 again. This is number 3, and then we draw in hydrogen, which is number 4.
See, the thing that has the most
The most things bound to it
is the highest priority.
is the highest priority if you don't have like oxygen, nitrogen, things like that involved. So for this one, since we don't have any of those involved, then we're just doing it based off how many things are bonded to that carbon
If you
that
did
are not
have,
hydrogen.
if you did have oxygen or nitrogen, then you do it the long way that Pelfrey taught.
I would look and see like kind of where those oxygens and nitrogens and stuff are bound. We can do another one of those like later to kind of like work through that.
Okay.
So yeah. So the idea is that I got my 1, 2, 3. Hydrogen's always 4. It's on the dash. Don't have to flip it or anything. So once again, this is moving in a clockwise direction. So this is also R. So we know at 4 we have another R group. Okay, so then we move to this last stereocenter here. And once again, we get closer to this double bond here, which makes this really easy because this double bond is going to be 1. Because you're looking at this carbon and it's got 4 things bound to it. 1, 2, 3, 4. It's got 4 bonds, right? So that's 1. Then I'm looking at this and I'm going, okay, going from here, moving out and moving here, how many things are bound to each of these? This we already kind of talked about having 2 carbons. This one also only has 2 carbons bound to it. It has this carbon and this carbon, right?
Hmm.
So then we move out further and we look at this one. This one's got 3 carbons bound to it. 1, 2, 3, right? 3 carbons bound to it here. This one also has 3 carbons bound to it. 1, 2, 3. So then we go, okay, cool. We've got to move out a little bit further.
Does it matter which way you move out, or just pick one and see
Just
what
pick one. Just pick one, see what happens. Sometimes it's a little bit easier to go one way or another. Like I already know since I'm here and I'm having to move out again, this has 4 carbons bound to it. So this is going to be a higher priority than either one of these. Because this is just CH3 and we don't care about hydrogens.
Could you
So
move?
it's really only got that 1 carbon bond right there, whereas this has 4. So this is going to be your higher priority here.
So could you move to the right instead of going up, or does it matter?
You could move to the right.
Okay.
There's no real purpose served in that. I just try to look for whatever is going to have the most things bound to it, because then I know it makes my job easier. So then that means that since this is a higher priority, this is 2, and then this is 3. But then remember, we always want to draw in whatever's not here, which is our hydrogens. And because this is a dash, this hydrogen has to be a wedge. There's always one and then the other. And what do we do with wedge hydrogens?
Flip
Class?
it.
You flip it. So this is 1, 2, 3. So 1, 2, 3 looks like an S. It's going counterclockwise, but we're flipping it, so it's an R. And then we're at carbon number 6, so it's 6R. Okay? So then this is what helps us complete our name. So then we just have to put it in order. So the thing that throws people off is the fact that this is STII. And people think, oh, alphabetical order. We don't really give a shit. I keep cussing, I really work on that. We don't really care about those beginning parts. We look at butyl and propyl. So we want to start with butyl, and we want to start with the lowest number and work our way higher. So then we would say 3-sec-butyl, 4-t-butyl, 6-isobutyl, 1-isopropyl, and then this is cyclohexane. So that gives us that part of it, and then this hexene, sorry. See, you catch me on my shit.
Get him.
And then this just basically goes at the beginning. So it's 3R, 4R, 6R. Just like that.
And now for the viewers, we always put that in parentheses.
Just because that way you're not confusing with anything else.
Somebody just asked me that on.
Nice.
On live chat.
Yeah. On live
We
chat?
got live
Okay,
chat
cool, we
going
can
on.
actually see it whenever I like have it here. I didn't know how far down it could go on the whiteboard, so I could have gone a little bit lower down. But yeah, so that's how you name that one. So, good?
Yes, sir.